Imagine the most powerful telescope humanity has ever built, suddenly discovering something in space that shouldn't exist. Not a planet, not a galaxy, but an object so strange that scientists begin questioning everything we know about the universe. Right now, the James Webb Space Telescope is looking deeper into space than ever before, almost to the beginning of time after the Big Bang. And what it might eventually see could be the most terrifying discovery in human history, the most powerful telescope ever built. When scientists launched the James Webb Telescope, their goal was simple: look deeper into space and further back in time. Unlike older telescopes like the Hubble Space Telescope, Webb sees the universe in infrared light, allowing it to peer through cosmic dust and observe the first galaxies ever formed. But sometimes the deeper we look, the more strange and unsettling the universe becomes. Galaxies that shouldn't exist. Soon after Webb began sending back data, scientists noticed something shocking. Massive galaxies appearing far earlier in the universe than theories predicted. These galaxies seemed too large, too organized, too evolved for such an early time after the Big Bang. Some researchers even wondered, did we misunderstand how the universe formed? Or is there something deeper happening behind the scenes of cosmic history? Another terrifying possibility: evidence of advanced alien civilizations. Webb is powerful enough to analyze the atmospheres of distant planets and detect chemicals linked to life. One day it might observe a distant world and detect something impossible: artificial light, megastructures around a star, or technological pollution in a planet's atmosphere. Signs that we are not alone, and maybe never were. Something older than the universe. But the most frightening discovery of all would be this: something that appears older than the universe itself. A cosmic structure that seems to have formed before the Big Bang. If Webb ever detects something like that, it would force scientists to rethink everything about the origin of reality itself. Because it would mean the universe might not be the beginning after all. But the deeper scientists look into space, the stranger the universe begins to appear. When the James Webb Space Telescope started sending back its first images, astronomers expected to see small, primitive galaxies forming slowly after the Big Bang. Instead, they found something shocking: huge galaxies, bright galaxies, fully formed galaxies. And they existed far earlier than our theories predicted. For decades, scientists believe galaxies took billions of years to grow and evolve. But Webb is showing galaxies that appear too massive, too mature, and too organized for such an early universe. Some researchers have even begun quietly asking a disturbing question: what if our understanding of cosmic history is incomplete? Or worse, what if something influenced the formation of these galaxies long before we thought it was possible? But strange galaxies are not the only mystery. There is something far darker hiding in the universe. Astronomers already know that most of the cosmos is invisible. Stars, planets, and galaxies make up only a tiny fraction of reality. The rest is dominated by mysterious forces known as dark matter and dark energy. These invisible components shape the entire structure of the universe. They control how galaxies move, how clusters form, and how the universe expands. But here is the terrifying part. We still don't know what they actually are. The James Webb Space Telescope may eventually reveal cosmic structures created by this hidden universe-vast formations that have remained invisible until now. Structures so enormous they could stretch across millions of light years. And then there is another possibility that keeps some scientists awake at night. A wandering cosmic monster. In the darkness between galaxies, there may be objects drifting silently through intergalactic space. Objects with gravitational power so intense that they bend light itself. Objects like a massive black hole traveling alone through the cosmic void. Imagine something like that moving through the universe for billions of years, undetected, invisible, until a telescope like Webb finally sees it. But perhaps the most unsettling possibility is this. The telescope may discover signs of life beyond Earth. The James Webb Space Telescope is powerful enough to analyze the atmospheres of distant worlds orbiting other stars. By studying the light passing through these atmospheres, scientists can detect gases linked to life. Oxygen, methane, water vapor. But one day, Webb might detect something even more shocking. Artificial chemicals, industrial pollution, or unusual atmospheric patterns that could only be produced by advanced technology. Evidence that an intelligent civilization exists somewhere in the depths of space. And if that moment ever comes, humanity will face one of the greatest questions in history. Are we truly alone? Or has the universe been filled with civilizations all along, quietly evolving under distant stars? For now, the James Webb Space Telescope continues scanning the deepest darkness of the cosmos. Every image it sends back reveals new wonders. But each discovery also reminds us of something profound. The universe is far stranger, far bigger, and far more mysterious than we ever imagined. And somewhere out there, the next discovery might already be waiting, the telescope that sees the invisible. One reason the James Webb Space Telescope is so powerful is because it observes the universe in infrared light. When the universe expands, light from very distant galaxies gets stretched into longer wavelengths. This process is called cosmic redshift. Because of this, some of the oldest light in the universe can no longer be seen by normal telescopes. But Webb was specifically designed to detect that ancient infrared light, allowing it to observe galaxies formed more than 13 billion years ago, very close to the time after the Big Bang. In other words, Webb is not just looking into space, it's looking back in time, the golden mirror that changed astronomy. The telescope's mirror is one of the most remarkable pieces of engineering ever built. It is made of 18 hexagonal segments coated in gold, forming a giant mirror about 6.5 meters wide. This makes it more than twice the size of the mirror used in the Hubble Space Telescope. The larger the mirror, the more light a telescope can collect. And the more light it collects, the deeper it can see into the universe. That's why Webb can detect incredibly faint objects billions of light years away, a telescope far from Earth. Unlike most telescopes, the James Webb Space Telescope does not orbit Earth. Instead, it sits nearly 1.5 million kilometers away at a special location called the second Lagrange point, often referred to as L2. This point allows the telescope to stay perfectly aligned with Earth and the Sun while remaining in deep space. Its giant sunshield, about the size of a tennis court, blocks heat from the sun, so the telescope can stay extremely cold. This is important because infrared observations require very low temperatures to detect faint cosmic signals. Studying alien worlds. One of Webb's most exciting missions is studying planets around other stars. These planets are known as exoplanets. When an exoplanet passes in front of its star, a tiny amount of starlight filters through the planet's atmosphere. The James Webb Space Telescope can analyze this light and detect the chemical fingerprints of different gases. So far, Webb has already detected water vapor, carbon dioxide, and methane in the atmospheres of distant worlds. These discoveries are helping scientists understand which planets might be potentially habitable. Discovering the first stars. Another major goal of the telescope is to observe the very first generation of stars in the universe. These ancient stars formed when the universe was only a few 100 million years old. Studying them helps scientists understand how the first galaxies formed and how heavier elements like carbon, oxygen, and iron were created. Without those elements, planets, and life as we know it would never exist. The future discoveries. Even though the James Webb Space Telescope has already made incredible discoveries, scientists believe its most important findings may still be ahead. The telescope is expected to operate for more than a decade, continuously observing the universe with unprecedented precision. During that time, it may reveal new types of galaxies, unknown cosmic structures, the chemistry of distant planets, and possibly clues about the mysterious forces shaping the universe. One of the most fascinating aspects of the James Webb Space Telescope is that it is not just, in many ways, it is a time machine. When we look at distant objects in space, we are not seeing them as they are today. We are seeing them as they were when the light first began its journey toward Earth. Light takes time to travel across the vast distances of the universe. Because of this, the deeper we look into space, the further back in time we see. For example, when Webb observes galaxies that are 10 billion light years away, it is actually showing us what those galaxies looked like 10 billion years ago. This means that astronomers can watch the history of the universe unfold by studying objects at different distances. The James Webb Space Telescope allows scientists to observe the universe closer to its beginning than ever before, approaching the era shortly after the Big Bang itself. And what Webb has already found during these early observations has surprised many scientists. Some of the galaxies Webb has detected appear to be far more massive and developed than expected for such an early time in cosmic history. According to previous models of galaxy formation, galaxies should have started small and slowly grown larger over billions of years. But Webb's observations suggest that some galaxies grew extremely fast, reaching enormous sizes much earlier than predicted. This raises new questions about how galaxies form, evolve, and interact. Did gravity pull matter together faster than we believed? Did early stars form in massive bursts of activity? Or are there physical processes in the early universe that scientists still do not fully understand? These discoveries are forcing astronomers to re-examine long-standing theories about how the cosmos evolved. Another area where Webb is transforming astronomy is the study of stellar nurseries. Across the universe, enormous clouds of gas and dust collapse under gravity to form new stars. These regions are often hidden behind thick cosmic dust that blocks visible light. Older telescopes could see only the outer layers of these clouds. But the James Webb Space Telescope, with its infrared vision, can see through the dust itself, revealing stars being born deep inside these dense regions. Inside these stellar nurseries, Webb has captured images of glowing filaments of gas, swirling clouds of dust, and newly forming stars surrounded by disks of material. These disks are especially important. Within them, particles of dust slowly collide and stick together, gradually forming larger and larger structures. Over millions of years, these structures can grow into planets. By studying these disks around young stars, astronomers are learning more about how planetary systems, including our own solar system, may have formed billions of years ago. The telescope is also helping scientists understand the complex chemistry of the universe. Inside molecular clouds and planetary atmospheres, Webb can detect the unique spectral fingerprints of different molecules. This allows astronomers to identify substances such as water vapor, carbon dioxide, methane, and ammonia in distant environments. These molecules are important because they play a role in the processes that lead to the formation of planets and, potentially, life. One of the most exciting areas of research involves exoplanets, which are planets orbiting stars outside our solar system. Over the past few decades, astronomers have discovered thousands of these worlds. But the James Webb Space Telescope is giving scientists their first detailed look at the atmospheres of some of these planets. When a planet passes in front of its star, a small portion of the star's light travels through the planet's atmosphere before reaching the telescope. Different gases absorb different wavelengths of light. By analyzing these patterns, Webb can determine which gases are present in the atmosphere. This technique allows astronomers to detect the chemical composition of distant planets that are hundreds or even thousands of light years away. Some of these planets are extremely hot, with temperatures high enough to melt metals. Others are gas giants larger than Jupiter. But scientists are especially interested in smaller rocky planets that might have conditions similar to Earth. In the future, Webb may help identify planets with atmospheres that could support life. The telescope is also providing unprecedented insights into the structure of galaxies. Galaxies are vast systems containing billions or even trillions of stars, along with gas, dust, and mysterious invisible matter. Many galaxies, including our own Milky Way galaxy, contain enormous black holes at their centers. These central black holes can have masses millions or even billions of times greater than the Sun. When matter falls into these black holes, it forms extremely hot disks that emit intense radiation. These energetic regions are known as active galactic nuclei. By studying these powerful objects, Webb is helping scientists understand how black holes grow and how they influence the evolution of their host galaxies. In some cases, black holes release powerful jets of energy that can extend for thousands of light years into space. These jets can shape the surrounding gas and affect the formation of new stars. Understanding these interactions is essential for building a complete picture of galaxy evolution. Another fascinating discovery made possible by the James Webb Space Telescope involves the detection of complex organic molecules in space. Organic molecules are chemical compounds that contain carbon. They are important because carbon chemistry forms the basis of life on Earth. In distant regions of space, Webb has detected molecules that may serve as building blocks for more complex chemical structures. These molecules can form in cold interstellar clouds or in the disks surrounding young stars. Over time, they may become incorporated into comets, asteroids, and planets. Some scientists believe that similar molecules may have been delivered to the early Earth by comet impacts billions of years ago. If that is true, then the basic ingredients for life may be common throughout the universe. The telescope is also revealing stunning details about the life cycles of stars. Stars are born, live for millions or billions of years, and eventually die. When massive stars reach the end of their lives, they can explode in powerful events known as supernova. These explosions scatter heavy elements into space. Those elements later become part of new stars, planets, and even living organisms. The iron in your blood, the calcium in your bones, and the oxygen you breathe were all created in the interiors of ancient stars. By observing these processes in distant galaxies, Webb is helping scientists understand how the universe became enriched with the elements necessary for life. Another important goal of the James Webb Space Telescope is to study the mysterious large-scale structure of the universe. On the largest scales, galaxies are not randomly distributed. Instead, they form enormous cosmic filaments and clusters that stretch across hundreds of millions of light years. These structures are thought to be shaped by the gravitational influence of invisible material known as dark matter. Although dark matter cannot be seen directly, its presence can be inferred from its gravitational effects on visible matter. Webb's observations of distant galaxies are helping astronomers map these cosmic structures and better understand how dark matter influences the formation of galaxies. The telescope is also contributing to research about the expansion of the universe. Observations over the past century have shown that the universe is expanding. Even more surprisingly, the expansion appears to be accelerating. Scientists attribute this acceleration to a mysterious phenomenon known as dark energy. Dark energy is believed to make up most of the energy content of the universe, yet its true nature remains unknown. By studying distant supernova, galaxies, and cosmic structures, Webb may provide new clues about how dark energy affects the evolution of the cosmos. Despite all these discoveries, the universe continues to surprise scientists. Every time astronomers build a more powerful telescope, they find something unexpected. The James Webb Space Telescope is already revealing a universe that is richer, more complex, and more mysterious than anyone imagined. New observations are constantly challenging old ideas and inspiring new questions. What was the universe like in its earliest moments? How common are planets that could support life? What exactly are dark matter and dark energy? And what other secrets remain hidden in the vast darkness of space? For now, Webb continues to quietly observe the cosmos, collecting data and sending it back to Earth. Each new image and measurement brings us a little closer to understanding the universe we inhabit. But at the same time, each discovery reminds us how much there is still left to learn. The universe is enormous, ancient, and filled with mysteries. And with the help of the James Webb Space Telescope, humanity has only just begun to explore it. Another remarkable capability of the James Webb Space Telescope is its ability to capture incredibly detailed images of distant, nebulae, vast clouds of gas and dust scattered across the universe. These nebulae are not just beautiful cosmic structures. They are the birthplaces of stars and planets. One famous region Webb studied is the Pillars of Creation inside the Eagle Nebula. These towering columns of gas stretch for light years through space and contain dense pockets where new stars are forming. Earlier images from the Hubble Space Telescope showed the outer surfaces of these pillars, but Webb's infrared vision allowed scientists to see inside the pillars, revealing young stars hidden deep within the dust. Some of these stars are only a few 100,000 years old cosmic infants compared to our Sun, which is about 4.6 billion years old. Webb has also provided extraordinary views of galaxies interacting with each other. Galaxies are not static islands of stars. Over billions of years, they can collide and merge with neighboring galaxies. These cosmic collisions can dramatically reshape galaxies, triggering intense bursts of star formation. One stunning example observed by Webb is the system known as Stephan's Quintet, a group of interacting galaxies located hundreds of millions of light-years. By studying these interactions, astronomers can learn how galaxies grow and evolve over cosmic time. These observations also provide clues about the future of our own galaxy, the Milky Way. In about 4 billion years, the Milky Way is expected to collide with the nearby Andromeda galaxy. When this happens, the two galaxies will gradually merge into a new, larger galaxy. Although individual stars are so far apart that direct collisions between them are extremely unlikely, the overall structure of both galaxies will change dramatically. Studying distant galaxy mergers allows scientists to better understand what might eventually happen in our own cosmic neighborhood. The telescope is also helping researchers investigate the atmospheres of giant planets within our own solar system. Even though Webb was primarily designed to study distant objects, it can also observe nearby planets with extraordinary detail. For example, Webb has captured images of Jupiter showing glowing auroras near the planet's poles, swirling storm systems in its atmosphere, and faint rings surrounding the giant planet. These observations help scientists understand the complex atmospheric processes occurring on gas giants. Webb has also observed Neptune, revealing its rings and high-altitude clouds in stunning detail. By studying these nearby worlds, astronomers can compare them with giant planets orbiting other stars, improving our understanding of how planetary systems form and evolve. Another exciting field of research involves the earliest phases of star formation. When clouds of gas collapse under gravity, they can fragment into multiple dense cores. Each core may eventually form a star, or even a small group of stars. During this early stage, the young star is often surrounded by a rotating disk of gas and dust known as a protoplanetary disk. Inside these disks, small grains of dust collide and stick together. Over time, these particles grow into pebbles, then rocks, then kilometer-sized bodies known as planetesimals. Eventually, some of these planetesimals merge to form full-sized planets. The James Webb Space Telescope allows astronomers to observe these disks with unprecedented clarity. In some systems, scientists have even detected gaps and rings within the disks, which may indicate that young planets are already forming inside them. These observations are giving researchers their clearest view yet of how planetary systems take shape. Webb is also helping scientists explore one of the most mysterious periods in cosmic history known as the Cosmic Dawn. This was the era when the first stars and galaxies began to shine in the universe. Before this time, the universe was filled mostly with hydrogen gas and very little structure. As the first stars ignited, their intense radiation began to transform the surrounding gas. This process, known as reionization, gradually made the universe transparent to ultraviolet light. By observing extremely distant galaxies, the James Webb Space Telescope is helping astronomers study this transformative era in unprecedented detail. Understanding the cosmic dawn is essential for explaining how the complex universe we see today first emerged. Another fascinating discovery involves gravitational lensing, a phenomenon predicted by the Albert Einstein theory of relativity. When a massive object such as a galaxy cluster lies between Earth and a distant galaxy, its gravity can bend the path of light traveling through space. This bending acts like a giant cosmic magnifying glass, making distant galaxies appear brighter and more distorted. The James Webb Space Telescope has captured stunning examples of gravitational lensing, revealing faint galaxies that would otherwise be impossible to see. By studying these lensed galaxies, scientists can probe the structure of the early universe in extraordinary detail. Webb's observations are also helping astronomers refine measurements of the universe's age. Current estimates suggest that the universe is about 13.8 billion years old. But determining this value precisely requires extremely accurate observations of distant objects. By studying ancient galaxies and supernova explosions, the James Webb Space Telescope may help scientists improve our understanding of how the universe expanded over time. These measurements could also shed light on one of the biggest puzzles in modern cosmology, the disagreement between different methods used to measure the expansion rate of the universe. Beyond the scientific discoveries, Webb is also inspiring people around the world. The breathtaking images it produces are not only valuable to researchers but also to educators, artists, and students who are fascinated by the beauty of the cosmos. Every image reminds us that our planet is part of a vast and complex universe filled with wonders waiting to be explored. The James Webb Space Telescope represents decades of work by thousands of engineers, scientists, and technicians from around the world. Its development involved collaboration between organizations such as NASA, European Space Agency, and Canadian Space Agency. Together, these groups built one of the most sophisticated scientific instruments ever launched into space. And yet, despite all the progress we have made, the universe still holds countless mysteries. New observations may reveal unknown types of galaxies, strange cosmic phenomena, or entirely new physical processes. Every time the James Webb Space Telescope turns its mirrors toward a new region of the sky, it has the potential to uncover something that no human has ever seen before. Some discoveries may confirm what scientists already suspect. Others may completely rewrite our understanding of the cosmos. But that is the nature of exploration. The deeper we look into space, the more questions we discover. And somewhere in the vast darkness of the universe, the next great discovery may already be waiting for us.